enhances our view of real world by overlaying what we see with computer-generated information. Today, this technology is prevalent in smartphone AR applications that require the users to hold their phone in front of them. By taking the image from the camera and processing it in real time, the app is able to disable contextual information or deliver gaming and social experiences that appear to be rooted in the real world. While smartphone AR has improved significantly in the past decade, its application remains limited. It is increasingly focuses on delivering a more holistic AR experiences throughout wearable smart glasses. These devices must combine an ultra low powered equipped with multiple sensors, including depth perception and tracking, all within a form of factor that is light and comfortable enough. This is an example of AR, like you can wear it. So from our real world, we have Snapchat that uses our face recognition to put funny filters on our faces. IKEA Place, which uses your space to replace the real IKEA furniture and like shows how it will look. Giphy World creates a real life movie effect using your camera, and there's other various types of apps that recognize plants, faces, and such. So what is AR Cloud? As I mentioned like 2 seconds ago, here is a GIF that Tom Holland, who plays Spider-Man, wearing the glasses, smart glasses with AR and AI built in. So we have given a general overview of AR. So what is AR Cloud? Let's assume that you want to visit a new city and you want to eat locally and you want to explore the city. You could just take out your phone and Google some restaurants close to you, surf through Zomato, and even find their menus and prices online. But it will take a lot of time and effort. Now let's imagine that while you're walking down the street, you could see all this information that you could have found in Zomato, Google, everything just laid out for you beside the restaurant digitally. So you put on your highly advanced technological glasses or lenses, as they do in movies, and you could just access all this information just glimpsing at the restaurant. With a phone, it will have taken up 15 minutes, but with just glasses, you could just get this information in seconds. So AR Cloud is exactly that, meeting the information online with the real world concept. In more fancy words, AR Cloud is a term for technology that enables delivery of digital content that is augmented over physical objects. So what are some in today's world, this is delivered using technological devices such as phones, headsets, and glasses. So what are some examples of this? There is this app called Skyview, which uses your geological placement and your camera to look around the stars, gaze at the stars. And then there's Google Lenses, which recognizes plants and displays information about it, for example.
And now we're going to see the mechanism beneath this platform. There are 3 steps, not 3 steps, they're all related actually. First, we need to collect the data. Then with the collected data, we will map the surroundings and detect the objects. And I will tell the term anchor, what anchor is. We need data so AR was the data of our surroundings, the environment surrounds us with the dynamic 3D machine readable data. That includes a massive size of data for AR Cloud, which is we cannot transfer the fast enough with 4G network because it's real time and the 3D objects are too huge to transfer. So we need at least 5G technology or more advanced technology to do that. Also, AR Cloud uses all kinds of technology for getting data. It uses the camera and IoT sensor devices data, and with taken data, it maps the area around with computer vision technology, and it also stores the 3D modeling of surroundings. With 3D with machine learning, it can understand the world around it and label 3D object, recognize behaviors or object or geoposes, etc. We can see an example of reality modeling with Sumo. With spatial mapping ability, we can create 3D map of the environment. Also, AR Cloud has 2 methods of mapping, which are different approaches in indoor mapping. It's indoor mapping and outdoor mapping. In indoor mapping, as we can see, outdoor data uses our GPS and geopose, actually GPS and or camera orientation basically, and in indoor it's more simpler than that. It's a lot less data, and we can see, for example, if you want to map your office or your room, you can use ARKit as wayfinding application. You can make a wayfinding application with ARKit, or since you don't need megapiles of data to demonstrate it, you just go with your scan the area with your camera, and if you like to, you can put AR objects, and then you can see what's there. Also, the other users see what's there. Also the other users see them as well. And outdoor mapping is another issue. When outdoor mapping is that we need the digital copy of the whole world, and it's immense data to scan. So one data isn't enough for example, one building. One camera frame isn't enough. Like there needs to be a lot of person taking pictures with camera, or using camera frame to build 3D model of that object, and it's also need to be dynamic and real-time mapping. So what is Anchor and spatial computing? Anchor is the connector between digital world we created in AR Cloud and the real world. When you put AR object in the camera with the AR Cloud application, it connects to the digital AR Cloud, and the other users see at the same spot as well. As you can see from this example, this phone planted hello world and smiley face here, and the other user seems at the same spot as well. Since this picture is from 2019, it's not very exact, but now with this technology, it's now almost exact. And you can see the anchor, what anchor really means. You put an object, AR object, in the digital world, and other users see them at the exact same spot and at the exact same time as well. What is spatial computing? Spatial is basically means 3D, or what an object occupies in 3D. Spatial computing has like geopose of the area and real-time mapping, and also it must be shareable. AR Cloud also use 3D detection and machine learning, and this helps object recognition, human recognition, object and human pose, its orientation and position in the coordinate spaces, and activity analysis, action recognition, etc. We can see a tree is labeled. We can label tree with this process in machine learning, and it's also included in AR. We can see NIANTEC using this example. NIANTEC is actually Pokemon Go's firm, while Pokemon Go uses cameras to get AR cloud data, the spatial data of the object, and use them for their AR world. As you can see, this ball is imaginary, and the users throw them at the real time, with real time, and and they all see the same image with them. You can see the technology behind those.
So what are the real applications of AR cloud, except the ones that Erkin mentioned? Actually, Google has one. It is a built-in feature in their Google Map. It was originally called Google's AR Navigation, but then they changed it up to Live View. It uses Google's Vision Positioning Services, VPS for short, with AR Cloud to deliver more accurate navigation. It was first demoed in 2018 and then was made available in August 2019. Then there's this company called Certify, and they developed the world's first AR technologies for cities. City AR, as their product is called, uses satellite imagery and mobile devices to visually recognize the streets around you and digitally enhances them for application ranging from navigation, tourism, ride-sharing, gaming, outdoor, advertising, and marketing. Lastly, even though I couldn't find a solid example for it, AI Cloud is highly used in enterprise applications and businesses. There is these data analysis applications for enterprises and businesses that use AI Cloud.